here we have a differential equation problem. It's actually an initial value problem where an equation is given and also a condition is given. So in trying to solving this equation, we observe that the equation can be solved using the separable method. So we're going to try to isolate variables x and y along with their respective differentials, dx and dy. So the given equation is of the form x prime equals to 3x t to the 4. So we can write x prime as dx dt equals to 3x t to the 4th. So now we're going to separate variables, so we can rewrite the equation as dx over x equals to 3 t to the 4 dt. As you can observe, then the equation we have on the left side, we have only x, and on the right side we have just t. So now we can move to integration on both sides. So the integral of dx over x is ln of absolute value of x. The integral of 3 t to the 4 dt is 3 t to the 5 over 5 plus, let's say, a constant that we can call C1. So the next step is to try to write, this is actually a solution of the differential equation in implicit form. So since we have a initial value problem, it is convenient to write the equation in its explicit form. That means we are going to isolate the dependent variable, which is in this case x. So how to accomplish that goal? So we're going to exponentiate on both sides. E to ln of absolute value of x equals to e to 3 t to the t5 over 5 plus e1. And then we obtain absolute value of x equals to e to 3 over 5 t to the 5th times e to c1. And then we can denominate or state that c2 is equal to e to c1. Is a way to rewrite this constant. Remember that e to c1 is a constant itself. So now our solution is going to be absolute value of x equals to c2 e to 3 over 5 t to the 5th. So getting rid of the absolute value, we have that x is positive and negative c2 e to 3 over 5 t to the 5th. So englobing both positive and negative c2 in a constant, then we can call c as positive and negative c2, and then rewrite our solution in explicit form as c e to 3 over 5 t to the 5th. So this is actually our explicit solution as x is isolated. But recall, the direction of the problem implies that we need to solve an initial value problem where an equation is given, the equation is already solved. Now we have to apply the condition x at 0 equals to 2 so that we can find the exact value of c. So in this particular case, then we can replace, recall the condition x at 0 equals to 2, correct? So we have that 2 equals to c, e to 3/5 times 0 to the 5th. So this term goes to 1, where it's actually 1. So we have that 2 is equal to c. So then we are in conditions to write the solution of our initial value problem, which is x of t equals to 2 e to 3/5 t to the 5th. And this concludes the solution of the initial value problem.